This video is a continuation of the priority rules. We demonstrated how to do first come, first serve in the earlier video and how to calculate these four measurements to evaluate how well this priority rule does. And so we were doing earliest due date, and so we sorted the list based on their due date. Just a reminder that flow time will change depending on how things are scheduled. And so flow time is calculated by taking a starting point is it takes 10 days to complete task C. We then add to that the 20 days, and so that would be done 30 days later because we have to do job C before we can do job A. And then once we're done with job A, we can do job B. So the 30 plus the 30, that means 60 days later we'll be done with job B. Now remember, you have to add this extra column here because we need to calculate flow time this way. So the total amount of flow time using this cumulative effect is 272, which is lower than the 300. So we'll probably do much better on the measurements. But to calculate lateness, we need to take care of the idea that we started on day 130 to actually do these jobs. And so 130 plus the flow time. And so that's what I did here is I just added the flow time, whatever it is, plus the 130, and I absoluted that. And so to calculate lateness here, we're simply going to take then our completion date and minus our due date in this case. And so a negative number would mean that we got it done early. We can copy that down. And so in this case, it looks like we got everything done early. Is that we were done before all the due dates. So average lateness in this case is literally 0 because we would zero out all of these things then. And so average lateness. Now let's go ahead and calculate these things again. I'm going to just copy these titles down here. Control C and then Control V. Utilization, remember, is our process time divided by our flow time. So the process time here. So where we calculated up here is the process divided by the flow time. So we're going to do the same thing here. We're going to take our process time or production time divided by our total flow time. So utilization went up. We could format this as a percentage. In fact, let's go ahead and do that. I'll format that as a percentage with 2 decimals. We probably should do the same up here. Format that as a percentage. Jobs in the system, completion time, this is 60 days. We can title these, and this is days. So jobs in the system, we reverse that. It's flow time divided by production total time. So there's 2.89. There's less jobs in the system. We're actually getting our jobs done and out. Completion time is just an average of these, or we can simply do it the way we showed you. Take this and divide it by the total number of jobs, which in this case is 5. And so it's only taking us 54 days as compared to 60 days, and then average lateness is 0 days because we're all done well before the due dates on those. So let's go down here and do shortest processing time. I've listed them from, well, I haven't sorted the list yet, so let's go ahead and do that. So I just made a copy of the list up here above. I'm going to now sort that. So we'll go to sort, and we're going to do a custom sort. And I'm going to sort by, not the due date, but I'm going to sort by the production. And I'm going to do it from smallest to largest. And so we'll double check that it did it correctly. So it's sorted on this production. So C, D, E, A, B. So shortest processing time to longest processing time. Once again, we can calculate flow. So we're going to start with this job here, 10 days. So we'll be done in 10 days. D, we have to do C first. So it's this plus length of time it takes us to do D. And then to do E, we have to finish A, C, and D first. And then we got to add what it'll get. Oops. Let's see, we got to do C and D first. And then we're going to add what it's going to take us to do E. And so E will be done 44 days later. And so we can copy that down here appropriately. Completion time. Remember, we have to add this extra column because we started on day 130, so we didn't start on day 0. So I'm going to do this. I'm going to absolute that again so that I can copy this formula down. So plus, and then we're just going to add to it the flow time. So I'll be done in 140, and then we can do our late here. And so once again, we'll take this minus this. We'll get a negative, meaning we're done 35 days before it's due. Copy that down. Now here we have some issues, so let's zero this out, zero that out, zero that out, and then we would have then the sum here. We wind up with 38 late days. So once again, let's evaluate this one. Utilization, remember it is, we forgot to add this up here. I'm going to add it up and come back and do that one. Remember, the process time is not going to change at all. The flow time is the only change that changes on order, so that's 94 divided by R up. We got to do the flow time again, so once I calculate that one, then we'll be set. So sum up the flow time. This is the thing that changes depending on how it's scheduled. 238. So this again is process time, production time divided by total flow time. And so you'll see that it actually has, I think, the best percentage of the 3 methods that we looked at so far. So it has the highest utilization. Jobs in the system, we reverse that. We divide the flow time by the process time. That tells us we have 2.53, so we have the least amount of jobs in the system so far. And so completion time will probably also go down. So this flow time divided by 5, our number of jobs. So it has the least amount of average. We're doing our jobs in 48 days, and average lateness ends up being the sum of late days divided by 5, which would give us 7.6 days. So lateness, actually first come, first serve, did a little bit better in regards to this than the best one, or the in regards to lateness, was the earliest due date, but it focuses on that actual measurement. So earliest due date will always do the best on average lateness, but on this one, the completion time and the utilization, jobs in the system, but average lateness was poorer than first come, first served. Let's do the last technique you have to look at. So once again, all I did is I'll make a copy of this. In fact, I can probably just make a copy of even using the total there, Command C, and then Command V. So let's make sure it's still working right. Yep, it is. But I need to sort this, of course. This one, we're going to go longest processing time, so we'll do a custom sort. But we're going to do it on, oops, let's cancel. I need to go back and highlight. Let's do, well, you can do this a couple different ways. Let's see if it's doing, there's where I need to check off, and so I'm going to sort on D, and I'm going to do it from largest to smallest. And so it arranged the list appropriately, and so now we can do the last of these. So we got flow again, we got completion, we got late, and of course we're going to calculate these measurements over here. So flow, this is our starting point, plus we add, oops, sorry, on the first one it's just the 30 days, and it starts on the second one. Then we have this plus this, so this will be done 50 days later, and then so on. So E will be done here 68 days later, 84 days later, and then of course we need to, I'm going to just copy this down. We'll double check that it's doing it correctly. So the 130, our starting point, this absolute cell address, and then we're adding to it the flow time, and so now we should be able to copy that down. Let's do a sum total of the flow time. $326. Let's do we'll copy the lateness here. Control C, Control V. It's just subtracting the completion. I'm going to subtract the due date from the completion. We're done 40 days early on this one. We'll copy it down. Looks like, so we'll zero these out here, 0, 0, 0. So they only have, on the last one, we are 49 days late. So interesting results here. The longest processing time, I think they were given due dates based on longest processing, but since we tackled those first, we got those done, and the one that had the shortest processing time, we probably gave a very early due date, and so it's way late now. And so we can actually figure that one out pretty fast. It probably will give us the worst of 9.8 days. So this was the worst in regards to lateness, but a lot of that has to do with the fact that we probably scheduled these, we knew they weren't going to take very long, and so we gave early due dates on those. And because we did that last, we did the hard ones first, the completion dates weren't necessarily taken into account our priority rule, our scheduling technique. Utilization, once again, process or production time divided by flow time. And then we can write, that's the lowest of our utilizations. And then we'll reverse that. We'll take flow time and we'll divide it by production time or process time. 3.4 has the most jobs in the system that we're working on, and the average completion time is then just this flow time divided by 5, or the average of the flow time, 65 days. This is not jobs in this. This one should just say 3.5, 3.5 jobs. This is titled days. So that's all there is to it. We now have compared these 4 techniques. You know, in some sense, first come, first serve was kind of in the middle of the road. Earliest due date did the best in regards to, of course, average lateness, which it should. The best one out of these techniques is probably shortest processing time. It has the best utilization, lowest number of jobs system. shortest amount of completion time. Not too bad on average lateness.